Hey guys, welcome back. This is Frank, and welcome to our IGCSE Co-Sci Physics revision videos. Our current unit is P4 Light in EM Spectrum. So I think today's video is going to be our penultimate video of the unit. So we're finally moving on from light into EM waves and the EM spectrum. So today I'd just like to introduce briefly a bit about EM waves, and I think I'll leave the uses and dangers in another video. But anyway. Let's start by looking at what we know as the EM spectrum. This is part of an image taken from Wikimedia Commons, so I've credited it here. And yeah, I think this is probably the most common thing you'll see if you search up like EM spectrum, like a spectrum of waves from like very dense to like very sparse. I don't know, and yeah, this is what we call the EM spectrum. But before we introduce the EM spectrum, I'd like to actually say something about EM waves. So this is actually, I don't think it's in the curriculum, but it's also good to know. Visible light is only a very small part of EM waves. So what we see right now, the colors that we see is only a small portion of like the actual range of EM waves, and we give different names to different frequencies of waves, or as you can see, like different sparsity, is that a word, like sparse, or like how density of waves. And so there are three properties I think that we should remember about EM waves. First of all, actually, you know what, I might write it somewhere down here so I can leave enough space. First of all of them transfer energy. So uh they transfer energy via vibrations of electric and magnetic fields. So when they kind of go, because they're waves, and then when they move around, they can they vibrate, and that is how they transfer energy. And secondly, unlike sound waves, they do not need a medium. So no medium needed. That means that they can travel. Actually, they can travel in a vacuum. All right. So there's no medium needed for them to travel around, so they can travel in a vacuum. And thirdly, I think this one's in the syllabus, so I'll label it red. In So they have, all of them have a fixed speed in a vacuum, and that is the speed of light we talked about in the previous videos. That is c, or 3 times 10 to the 8th meters per second. All right, that's the speed for all EM waves. I'll just write here, all EM waves. They all have the same speed of 3 times 10 to the 8th meters per second in a vacuum. And in air, it's, well, it's a little bit different than a vacuum, of course, but the difference is negligible. So there's actually, as far as we're concerned, we will still use 3 times 10 to the 8th meters per second. So yeah, that's something you'd like to know. And okay, so back to our EM spectrum. So as I've said, we name different frequency of waves differently. So starting from the most frequent, is called gamma ray. Actually, I might just pick. Oh, no, it's fine. Uh, Starting from the most frequent, we have gamma rays. So these are the rays that are used to, like, in hospitals usually, because they are very powerful, and only a small amount would be able to kill cells. So they're used to like treat cancer and stuff. But yeah, we'll leave that to a later video. So starting from the most frequent is gamma rays. And you don't have to know that, but just as a fun fact, the wavelength is around 10 to the 12, 10 to the negative 12 meters. The wavelength is like the length between like two peaks, I guess is what you call it. And that's only about 10 to the negative 12 meters. And just for reference, it's about the same size as an atomic nuclei. So like, you have a nucleus, of an atom that's about the size, about the wavelength of a gamma ray, and the frequency is. I'll move this down a bit. The frequency of gamma rays, is around. Move this down here. Frequency is around 10 to the 20th uh, hertz. So yeah, just so you know. And after gamma rays, we know what we know as over here probably X-rays. So I'm pretty sure you're familiar with X-rays, because that's what they use in hospitals to check, check your bones, and if they take an X-ray image, they can see through your skin and stuff. So yeah, X-ray has around a wavelength of wrong color, around the wavelength a wavelength of around 10 to the negative 10th meters, and the frequency is around 10 to the 18th hertz. All right. So after X-rays, we have what we call ultraviolet. So ultraviolet, violet. So ultraviolet, as the name suggests, is like above violet. So yeah, the wavelength is actually only still only 10 to negative 8 around meters, and the frequency is 10 to the 16th hertz. All right, so as you can see, as the waves are becoming less and less dense and more sparse, the frequency is getting lower and the wavelength is getting longer. And after ultraviolet, we have a range of what we call visible light. So these are the light that are most familiar to us, or I'll just write over here, visible light. Uh, Visible light has a frequency of around 10 to the actually 0.5 times 10 to the negative 6 meters. So as you can see, pretty much we every like one every we when we move from one type of wave to another, we time the wavelength by around 100. So it's like 100. The wavelength is around 100 times the previous wave or something like that. I mean, you don't have to know that for the syllabus, but it's a fun fact to know. And the wavelength, the frequency is around 10 to the 15th hertz. And as we move on, after visible light, we have infrared. So, oh, sorry, I forgot to mention like the approximate scale. So, X-ray is about the same size as an atom. Ultraviolet ray is about the same size as a molecule. Visible light is about the same size as a protozoan, or like those germ-like early creatures. I don't know. And we have infrared, which has a wavelength of around 10 to the negative 5 meters, and the frequency is only 10 to the 12th hertz. And that's about the same size of a needle point, so it's still pretty small, but yeah, we're getting bigger. And then we have microwave. So over here is microwave. Microwave is has a wavelength of around 10 to the negative 2 meters. So that's, I believe, is about 1 centimeter. So the frequency is only 10 to the 8th now. Uh, so yeah, around 10 to the 12th and 10 to the 8th. And finally, we have radio waves. So radio waves are the longest, and they have a wavelength of about 10 to the third meters. So that's about the size of a building. So that's like a kilometer. And the frequency is only 10 to the fourth hertz. So like around 10,000 hertz. So yeah. And fun fact, radio waves, as the name suggests, is used for like our radio. So if you have like if you see your radio, you can see like AM and FM stands for amplification, modify, and frequency modify, I believe. I might be wrong there, but yeah, radio waves are carried through like radio content, like the radio broadcast you listen to in cars is broadcasted through radio waves. So yeah, they have a very long wavelength, so they are very good for like traveling very far, and it reflects off hills in the upper atmosphere, so it's good. But as I've said, we'll leave that for later. Anyway, so here is the full series. I believe you have to remember that for the curriculum. So I don't know. There are many ways that you can remember it. Actually, my friends invented some like really interesting mnemonics. Like if you go from right to left, you get, I believe you get R M I V U X G. So that stands for real men in Vegas uses uh X-ray guns. I don't know, just fun stuff. You can come up with your own mnemonics probably. And the way I remember it actually is if you start, I'll leave it here actually. If you start from visible light, and you know that visible light goes from red all the way to violet, right? So these in between is what we call visible light. And from violet, you can go on to what we call ultraviolet, because apparently it's above violet. And then from red, you have infrared, because it's apparently below red. And visible light, ultraviolet, infrared, and then X-ray is slightly above ultraviolet, because you still see that in hospitals, and I'm pretty sure, actually I'm not pretty sure, but like I think most of you have experienced what it's like to take an X-ray image before, so it's pretty safe, and you still pretty commonly see it around. So yeah, that's just above ultraviolet. And then after X-ray, you would get gamma rays. So these are the things. Gamma ray is something that you wouldn't like see in everyday life unless you're fighting cancer. So yeah, or you're seeing someone fighting cancer, and that's what they use. So you know that. And below infrared, you have microwaves, because well, they're micro and they're small, and they have long wavelengths. Actually, microwaves have long wavelengths, which is interesting if you think about it. And infrared is like below red, but I guess it's talking about frequency. So yeah, microwave, and then you have the longest. Always remember the longest is radio waves. So yeah, there you have it. Start from visible light, you go left, and then you go right, or you go right and then you go left. But you do it eventually. But yeah, I guess it comes with practice, and after some practice, you'd be able to memorize this image forever, and hopefully that will help you on the test. And finally, before we wrap up, I'd like to add a little bit of extra content about wavelength. Um, how wavelengths and frequency and velocity are related. So there's actually a mathematical relation right over here uh, that goes wavelength. So wavelength is represented using lambda equals velocity over frequency. So right over here, wavelength, which is measured usually in meters, equals velocity over frequency. So this extra, but I think it's still interesting to know. So velocity is measured in meters per second, and frequency is measured in hertz. And yeah, there you have it. If you are ever wondering how wavelengths and frequency are related, we know that the velocity in air is constant, 3 to the 10, 3 times 10 to the eighth meters per second. So wavelength equals velocity over frequency, and you can kind of try to calculate that yourself through this in this with this graph. Anyway, so to sum up, today we talked a little bit about EM waves and the EM spectrum. We talked about we talked about what EM waves are, the properties of EM waves, the sequence of EM waves, the EM spectrum from gamma ray to radio wave, and we talked about how to remember it using mnemonics. Reelman Vegas use X-ray guns. I find it hilarious. And visible light. How to go from visible light to like infrared and ultraviolet, and then microwave, radio wave, X-ray, gamma ray, and we also talked a little bit about the extra stuff about wavelength and velocity and frequency and the mathematical relation between them. So yeah, not a densely packed video, but I hope you find it helpful, and I'll see you guys in the next video. Hey guys, just one last word before you go. I was just rewatching my recording and I realized I messed up the last part a bit. So yeah, I've reorganized the board, and you can see Real Men Vegas use X-ray guns here, and I have corrected my spelling of Vegas. Sorry for people living in Vegas. But anyway, um, just quick clarification that this is wavelength going from high to low, so wavelength decreasing and frequency increasing order, and the graph over here and the one that I wrote over here is of wavelength increases and frequency decreases. So yeah, just so you know, in the exam you might be asked both. So they might ask you like whether it's frequency increases or frequency decreases, or wavelength increases or wavelength decreases. So yeah, depending on that, you should write the correct order. And yeah, that's all for today. And thank you for watching. And I'll see you guys in the next video. Bye.